Hey everybody, up until this point in class, we've been talking about atoms and singular atoms. Well, now we're going to start focusing on the bonding, when those atoms come together and form molecules and compounds. Because in the real world, we have so many different compounds and elements and molecules that we come in contact with on a daily basis. So we're going to be focusing on specifically the covalently bonded molecules in this unit. So I'll share my screen. All right, so we're going to just go into a little introduction into bonding here and then naming and formula writing for covalent molecules. So first off, we are going to be talking about the attraction that exists between two different atoms in this particular unit, okay? And these are going to be forming compounds. With our covalently bonded molecules, though, we're going to be calling them molecules, and we'll get into that a little bit more later on. Chemical bonds can exist depending on how the electrons are interacting in between those two atoms. So we have two different kinds of bonds that we're going to be talking about. The first one is going to be ionic bonds. And ionic bonds exist between a metal and a nonmetal. So when we look at the periodic table, we know that the metals exist on the left side and the nonmetals exist on the right side. And we know that the electronegativity, let me just draw on this here for a second. The electronegativity trend increases to the right of the periodic table and up. We know that metals are over here, and we know that the nonmetals are over here. So comparatively, there's a big electronegativity difference between the metals and the nonmetals. So when you have this big electronegativity difference, when one thing, the nonmetal, has a high electronegativity, and when the metal has a weak or a low electronegativity, that nonmetal can pull the electrons towards its nucleus, leaving you with a positive ion and a negative ion. Or, like we know, that's going to be your cations and your anions that we talked about in the last unit. So, ionic compounds exist when that transfer of electrons has occurred and the nonmetal has gained the electrons and the metals have lost the electron. And we know that opposites attract, so that positive ion would then be attracted to that negative ion, holding those two things together. So again, ionic bonding is between a metal and a nonmetal, or a positive ion and a negative ion. So when we look at these compounds here, sorry, we're trying to identify which one of these are held together by ionic bonds. So we're looking again for metals and nonmetals. So NaCl is ionically bonded because it has a metal and a nonmetal. K3N has a metal and a nonmetal. So is MgBr2 and then Al2O3. CO2 is two nonmetals and N2 is two nonmetals as well. You can see in this picture down here at the bottom how these ions come together, how you can have one sodium atom and one chlorine atom. The chlorine takes the electron from the sodium, so it forms a negative ion with the chlorine, a positive ion with the sodium, and then it forms this crystalline structure here where all those positive and negatives come together and attract themselves to each other. All right, covalent bonds, though, those exist between two or more nonmetals. And this is not a transfer of electrons. This is going to be a sharing of electrons because the nonmetals typically have high electronegativities. So they have more similar electronegativities than, for example, the metal and the nonmetal. And so one can't overpower and take the electrons from the other. So they have to share the electrons between their nuclei. And they can share differing numbers of electrons, forming a single, a double, or a triple bond that we'll be talking about later on in this unit. You can see in these pictures here, though, that the electrons are shared in between the two nuclei, allowing each nuclei to have 8 total valence electrons to get that stable electron configuration that we've been talking about. Here in the CO2, you can see that they share 2 pairs of electrons between the carbon and each oxygen. So let's see if these are held together by ionic bonds or covalent bonds. So we've got a mix of names and formulas here. So MgSO4, again, you always just want to ask yourself if it has a metal or a nonmetal. Well, this one has a metal and some nonmetals, so this is going to be held together by ionic bonds, letter A. Dinitrogen tetroxide. So nitrogen is nitrogen, and then oxide is oxygen. So that's two nonmetals, so it's going to be covalently bonded. Aluminum chloride, aluminum is a metal, chlorine is a nonmetal, so that's going to be ionic. SO2, that's two nonmetals, sulfur and oxygen, so that's got to be covalent. And then two fluorine atoms, those are two nonmetals, so it has to be covalent as well. Now there's some things called diatomic molecules. And diatomic molecules are atoms that don't exist by themselves. They're more stable, existed, bonded to themselves. And so they will always be represented by an H2 or an F2 or a Cl2 because they don't exist as an H or an F or a Cl. So there are 7 diatomic molecules on the periodic table. They're hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. There's different ways that you guys can remember what these diatomic molecules are. A very common one is Brinkelhoff. Like this, Brinkelhoff, and that'll help you remember which atoms are considered diatomic molecules. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. You can also look at the periodic table. There are 7 diatomic molecules, and they make a 7 right here on the periodic table over here, and plus hydrogen over here on the left side. Whatever way you need to do to remember what those 7 diatomic molecules are. These are some common covalent names. You won't follow the IUPAC rules for naming and formula writing using these ones. These have common names that you must remember and go by. So ozone is O3, methane is CH4, hydrogen peroxide is H2O2, water, of course, we know this one is H2O, and then ammonia is NH3. Make sure you commit those to memory. All right, so let's take a look at how all the other things are named following IUPAC rules. So here I've put several examples of covalent molecules and their names. So you can see that carbon dioxide is CO2, nitrogen monoxide is N2O, sulfur hexafluoride is SF6, carbon monoxide is CO, and then tricarbon octahydride is C3H8. So when are prefixes not used with the element's first name? So let's look at these first names here. We've got carbon, dinitrogen, sulfur, carbon, and tricarbon. So when are prefixes not used? In the carbon dioxide, the sulfur hexafluoride, in the carbon monoxide? Well, they're not used when there's only one of the first element. Okay, so we do not use a prefix if there's only one of the first element, because in tricarbon, we've got 3 carbons. In dinitrogen, we have 2 nitrogens. When is the prefix mono used then? So let's take a look and see where we have mono. So we have mono here, and we have mono here. So we use the prefix mono if there's only one of the second element. Because we don't use the mono on the first element. Notice we didn't use it with monocarbon dioxide. Nope, nope, nope. It's only used if there's only one of the second element. And what do the endings of all the covalent molecules have in common? They all end in "ide." They all end in "ide." Okay? They all have the same suffix except for those common ones that we talked about on that last slide. So no prefix on the first element if there's only one of it. If there's more than one, we use the prefix. The prefix mono is used on the second element if there's one. And the endings of all the covalent molecules have in common, they all end in "ide." And you can see a list of the prefixes on the first page of your packet. So let's see if we can apply the information that we just talked about. So we want to see if the names are written correctly for each of these following molecules. We need to correct it if it's wrong. So Si2Br6, is that silicone hexabromide? No, that's wrong. The first one, silicone, would imply that there's only one silicone, but there are two. So we need to put that prefix with that first one. So this should be disilicone hexabromide. Letter B, nitrogen trifluoride, NF3 is NF3 nitrogen trifluoride. Yep. Remember, we don't use mono for the first element. Letter C, S6O, hexasulfur oxide. Note, the second element always gets a prefix, so it should be monoxide, hexasulfur monoxide. P4S5, is that tetraphosphide pentasulfide? Well, there is 4 phosphorus, and there are 5 sulfurs, but this is not right. Look carefully at this first name, tetraphosphide. We only use "ide" on the second element, not on the first, so this should be tetraphosphorus pentasulfide. We only change the ending on the second name. And then B6Si, is that hexaboron monosilicide? And sure enough, it is. So let's see if we can name these molecules going with what we just talked about. So if we have NO, that would just be nitrogen monoxide. No mono on that first element name, remember. XeF6, that would be xenon hexafluoride. Make sure we change the ending of the second element to "ide." And then PCl5 would be phosphorus pentachloride. So let's go over these rules and make sure we have the rules written down in our notes. So the elements are going to be written in the same order in the name as they are in the formula. So whatever's written first in the formula will get written first in the name. Like we've talked about, we don't use the prefix mono on the first element. If there are more than one, then yes, use a prefix on the first element, but no mono on the first element. The second element will always get a prefix though, always. The second element always gets a prefix. The ending of the molecule is "ide." So you're going to change the ending on the second element to "ide." And then this last piece, we haven't talked about this yet, but we're going to drop the vowel on the prefix, except if it's di or tri, when your element name begins with a vowel. So for example, what this means, let's say that we have O6, for example. Well, 6, the prefix is hexa. O is oxygen. So we need to drop the vowel on the prefix. We're going to drop the A, and we would make that hexoxygen. Hexoxygen. Okay, hexoxygen. So drop the A or the vowel on the prefix if the element begins with a vowel. All right, so here are your prefixes for the first 10. We will not go over that, so you don't have to know anything above 10. So we have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Most of these are things that we have heard before in other aspects, so we should be able to apply these quite easily to our covalent molecules. Again, they're written on the first page of your packet if you don't want to write these out yourselves. All right, so let's practice writing some names. Okay, so CO2, first element doesn't get a prefix if it's just one. Second element always gets a prefix, so this would be carbon dioxide. SO2, same thing, but we're just going to change that first one to sulfur, so sulfur dioxide. S2O3, the first element does get a prefix if there's more than one, so disulfur trioxide. Number 4, the second element always gets a prefix. So this is where we tend to forget to write a prefix with the second one, so N2O would be dinitrogen monoxide. And then PCl5 would be phosphorus pentachloride. Formula writing, the prefix tells you how many there are. So selenium hexafluoride, selenium is SeF6. Disilicone, di is 2, so Si2. Hexabromide is 6, so Si2Br6. Diboron, B2. Monosilicide, Si. Iodine pentafluoride, so IF penta is 5, IF5. And then hexaboron monosilicide, B6, Si. Okay. So on this one, I want you to try these out on your own first. So pause the video, write these out, write the formulas for 1 through 7, write the names, I'm sorry. Write the names for 1 through 7, write the formulas for 8 through 13, pause the video, do this yourself, and then start the video back up so you can check your answers, okay? So pause, and then check your answers, okay? If you have any questions about naming and formula writing or about the difference between ionic and covalent itself, just let me know. I'll be happy to help. You're going to be practicing on page 5 in your packet before you move on to the next video. Thank you.